Assalamualaikum and a very good morning to everyone. Today, our group will be presenting our project on reflective concrete. In these presentations, we will discuss what reflective concrete is and how it works, its thermal performance, energy savings, potential benefits, current applications, and research trends, especially in Malaysia. So allow me to introduce our team members, which is first Nazri Aini binti Nazri, Nur Atika binti Syarul, and me, Nur Adil Farsha binti Muhammad Fauzi, and lastly Lob Ahmad Dani bin Lob Mahdi. So let us begin with introductions. As we know, global temperatures continue to rise. Reducing heat in buildings has become an important challenge in the construction industry. In Malaysia, the hot and humid climate increases the need of air conditioning, resulting in higher energy consumptions and electricity costs. Conventional concrete absorbs a large amount of heat from the sun, which contributes to urban heat island (UHI) effects and makes outdoor areas hotter. Reflective concretes offer a more sustainable alternative because it reflects more sunlight and absorbs less heat. This helps keep the surface cooler, improve thermal comfort, and reduce the need of artificial cooling. This study examines the performance of reflective concrete, its benefits, current applications, and its potential to support sustainable constructions in Malaysia. Next, let's continue with methodology. This study was based on a review of published research related to reflective concrete and heat reduction technologies. Information was collected from recent journals, articles, conference papers, and technical reports obtained from reliable academic sources. Each study was examined and compared to understand how reflective concretes perform in terms of reducing heat, improving energy efficiency, and supporting sustainable constructions. The information together was then organized and analyzed to identify its key benefit, current applications, research development, and future potential with particular attention to its suitability for Malaysian climate.
In this part, we would like to talk about thermal performance. So, what is thermal performance? Thermal performance is a measure of how effectively a material, object, or entire building manages the transport of heat. It evaluates how well a substance responds to changes in temperature, resists heat flow, or stores and releases thermal energy. One of the features that it provided is thermal resistance. Thermal resistance is the ability for the material to resist the flow of heat. High heat resistance allows the material to block heat from moving through it, allowing indoor temperatures to reduce by the cooling features provided. The applications for the reflective concrete has practice in construction such as roofing and pavements, which gives significant impact on cooling system where temperatures may drop from 1 to 7 degrees Celsius for indoor air temperatures. The effectiveness of applying reflective concrete has made an impact on engineering industry by tackling the issues regarding cooling system in an efficient way. So now we can talk about energy saving. Other than aiding the cooling system, it also helps promoting energy saving features from the thermal performance. The ability of reflective concrete to reflect the heat, making the indoor air temperature to be more cooler, reduces the demand of air conditioning. This can also be applied to civil engineering properties such as pavements by reducing urban heat and improve energy efficiency. For buildings, it helps reduce the usage of air conditioning because of lower heat flux, making the indoor air much cooler than most buildings. From the community and environment aspects, it helps with the utility bills by consuming less electricity. With less energy consumption, emissions of greenhouse gases can be reduced significantly by applying this material.
First, let's look at the benefits of reflective concrete. Reflective concrete provides benefits in four main aspects, which are energy consumption, the environment, the economy, and society. For energy consumption, we can see that reflective concrete helps conserve electricity because it reflects more solar radiation instead of absorbing heat. As a result, buildings stay much cooler, reducing the need for air conditioning and lowering electricity consumption. It also provides better thermal protection, helping maintain a comfortable indoor temperature while reducing reliance on cooling systems. For the environment aspect, reflective concrete reduces carbon emissions by lowering cooling energy demand. Study shows it can reduce greenhouse gas emissions by around 5.25 kilograms of carbon dioxide per square meter. It also helps mitigate the urban heat island effect, where reflective surfaces can remain 10 to 25 degrees Celsius cooler than conventional concrete. In addition, using recycled crushed glass as part of the concrete mixture reduces construction waste and supports a circular economy. For an economic perspective, reflective concrete offers better durability and long-term performance. Although the initial cost may be slightly higher, its longer lifespan and reduced maintenance make it more cost-effective over time. Using recycled materials also help reduce raw material costs and waste management expenses. For society, reflective concrete improves human thermal comfort by creating cooler indoor and outdoor environment. It also enhances the appearance of urban areas, providing both aesthetic value and improved living conditions. Next, let's compare reflective concrete with conventional concrete. Reflective concrete has several advantages over conventional concrete. Firstly, it reflects more sunlight, which helps keep the surface a lot cooler, while conventional concrete absorbs more heat and reaches higher temperature. As a result, reflective concrete reduces the need for air conditioning, leading to lower electricity consumption and better energy efficiency. It also has a lower environmental impact because it reduces carbon emissions and can incorporate recycled materials such as crushed glass. In addition, reflective concrete provides a cooler and more comfortable environment for both pedestrians and building occupants. Although it has slightly higher initial costs, the savings in energy and maintenance make it a much more cost-effective choice in the long run. Finally, let's look at the current uses and potential applications of reflective concrete. Globally, reflective concrete is already widely used in roads, sidewalks, parking lots, and pedestrian walkways to reduce surface temperature and improve outdoor comfort. It also commonly applied in residential and commercial buildings, where it helps improve energy efficiency by reducing heat absorption. In addition, it is used in structural components such as building panels, exterior walls, and precast concrete elements, as well as in green buildings and sustainable energy systems, just to enhance overall building performance. Now, let's look at its potential applications in Malaysia. Malaysia has a hot and humid tropical climate, making reflective concrete highly suitable for our environment. It can be used in climate-resilient infrastructure, such as highway, bridges, coastal structures, public roads, and pedestrian walkways, where reducing surface temperature can improve durability and public comfort. It also has strong potential in smart city developments and institutional areas, including university campuses, recreational parks, and public spaces. Cooler pavements and surrounding areas can improve the quality of urban living while reducing the urban heat island effect. Furthermore, reflective concrete also supports green building and eco-construction initiatives, which align with Malaysian sustainability goals. It can be implemented in commercial and industrial developments such as high-rise, apartment, office buildings, shopping complexes, warehouses, logistic hubs, and data centers. Finally, it can also be adopted in public sector facilities, including government office, hospital, schools, and educational institutions where reducing energy consumption can lower long-term operating costs.
For this section, I will explain the current research trend, development, and future prospect of reflective concrete. Based on the reviewed studies, current research mainly focuses on improving the thermal performance of concrete through the development of self-cooling cement, radiative cooling material, and high albedo reflective surfaces. Researchers are also investigating reflective pavement and sustainable concrete material by incorporating recycled material such as nano-TiO2 additive and phase change material or PCM, which can store and release thermal energy efficiently. Moving on to current development, several advanced technologies has been introduced. These include reflective cementitious composite with enhanced solar reflectance, infrared reflective coating using titanium dioxide microsphere, and dual-layer insulation system that combine reflective surfaces with radiant barrier. In addition, reflective concrete is increasingly being integrated into smart building design and sustainable construction practices to improve energy efficiency and indoor thermal comfort. Looking at future prospects, reflective concrete is expected to play an important role in smart city infrastructure and climate-resilient urban development. Future research is likely to focus on multi-functional concrete that combine cooling, insulations, and thermal energy storage capabilities in a single material. Furthermore, large-scale implementation of reflective concrete in roads, buildings, and public infrastructure is expected to support net zero carbon construction and sustainable urban development. In conclusion, reflective concrete is evolving from a conventional cooling material into an advanced and sustainable technology that can contribute to energy efficient and climate resilient cities in the future. Reflective concrete is a cool pavement that reflects more solar radiation than conventional concrete, reducing heat absorption and surface temperature. This helps mitigate the urban heat island effect and improve urban thermal comfort. In terms of thermal performance, it significantly lowers surface temperature and reduces heat transfer to surrounding area, which decreases cooling demand in nearby buildings. As a result, it contributes to energy saving through reduced air conditioning usage. Compared to conventional concrete, reflective concrete performs better in controlling heat gain due to its higher reflectivity. The benefits of this innovation are environmental, economic, and social. It reduces urban overheating, supports climate change mitigation, lowers energy consumption and costs, and improves outdoor comfort for users. Overall, it offers better thermal regulation compared to traditional material. In Malaysia, reflective concrete has strong potential for application in roads, parking area, pedestrian walkways, campuses, and commercial development due to the hot and humid climate. Current research also focuses on improving its performance using materials such as nano TiO2, recycled material, reflecting coating, and phase change material (PCM) to enhance cooling efficiency, durability, and sustainability for future smart and energy efficient urban development. Overall, reflective concrete is a promising sustainable material for energy efficient and climate resilient urban development.
So for the conclusions, based on the study review, reflective concrete is a promising material for creating cooler and more energy efficient buildings and urban space. Its ability to reflect solar radiation helps reduce surface temperature, lower cooling demand, and improve thermal comfort. Besides reducing electricity consumption, it also helps minimize the urban heat island effect and supports more sustainable construction practice. As research continues to improve its performance and durability, reflective concrete has strong potential to be widely used in Malaysia, particularly in buildings, roads, and public infrastructure, contributing to a greener and more climate resilient future. So this is our reference for this project of reflective concretes, and I think that's all from us group 3 for this case study. Thank you.